anytime you take particles of one substance and spread them out inside another substance, and this process is something called dispersion, is that there are three types of mixtures that you can get out of this. The first one is solutions, the second one is suspensions, and the third one are colloids. So here's what we have here. A solution. Solutions are defined this way. In a solution, the particle that's mixed in, the particle size in a solution is less than 1 nanometer. So it's really tiny, less than 1/1000th of a meter, really tiny here. And in a solution, the mixture is homogeneous. And so in this case, the root homo here means same, and so basically it means it is spread out the same throughout the whole mixture. So that you wouldn't have, if you have a salt water solution, is that the salt ions are mixed out sort of entirely through the whole thing. There aren't more of them at the bottom than there are at the top. They are uniform throughout the whole substance. They are homogeneous, and the particles are very, very small, less than 1 nanometer. On the other hand, in a suspension, the particle size is greater than 100 nanometers. And so still pretty small, but at least 100 times, usually more than that, larger than the particles in a solution. And these particles in a suspension are large enough that they settle out. Is that they basically have enough mass that if you mix up a suspension, then they'll all sort of fall their way out. They'll work their way to the bottom, and you'll end up with stuff at the bottom of your container. Whenever they fall out, this is called a precipitate. If you do have one of these here, if you're creating one as you're going here, an example of this would be take river water. If you take river water when it's been flooding and it's really sort of dirty water, you take it up and it's sort of brown water, but if you let that sit aside for a little while, eventually all the stuff that's in it will settle to the bottom. The reason why is because that's a suspension. If you, on the other hand, to go down to the ocean and take salt water, set it aside, it's pretty much always going to be salty for the whole thing. The salt will not settle to the bottom. So if it doesn't settle, then it's generally going to be a solution of these two guys because the particles are too small. If it does settle, it's typically going to be a suspension. So suspensions, the particle sizes are greater than 100 nanometers, and the mixture is heterogeneous. Hetero means different because of the fact that basically the particles will eventually settle out. But these are only two of the types of mixtures that we talked about. Let's see if I can get my guy to go on here, page down. Okay, but actually before we get to our third one here, particles in solutions are generally too small to be mechanically filtered. And so, but particles in suspensions can be filtered out. They're big enough for this to work. So if you were basically take salt water and put it through filter paper and try to filter it out, you could never get the salt out. You cannot filter out particles in a solution. They're too small. In suspensions, though, you can filter them out. If you take that river water and put it through a coffee filter, you can filter out most all the bad stuff that's in there. That's why you have like water filters that you may have for drinking water. Basically, is that if it's a suspension in it, it's got those other particles, that'll pull those out no trouble. Now, one way to tell whether you've got a solution or a suspension, and outside of waiting for it to settle out, is to use something called the Tyndall effect, and that's what we have a picture of right here. So the large size of the particles in suspension cause light passing through to be scattered, and this is called the Tyndall effect. You can sort of see the picture that we have here. We have a green laser that's being basically shot through a suspension, and because of the fact it's shot through a suspension, you can see the beam. Basically what's happening here, and so if I can find a pen that'll work this way, is the light comes out of the laser. Whenever it basically hits these particles, they're large enough to cause the light to sort of jump off in some other direction, and so it bounces off. It doesn't just go straight through, and so any light that's coming out here bounces off in some direction. And so including what'll happen is it'll bounce off and it'll come straight towards your eye. And so that way you can see the beam going through the liquid here. As opposed to, and I sort of covered it up, so let's bring this back out here. As opposed to sort of out in this region where it's going through air. You can't see the laser beam there. The reason why is because there aren't large particles in the air to scatter the light. You can only see it when it's going through the suspension where the particles are large enough to scatter the light and send it to your eye where you can see that beam. This is also, this Tyndall effect explains why sometimes, if you go outside at certain times, you can see sunbeams. Is that what you're seeing here is a suspension in the air. There are dust particles in the air that are large enough to reflect the sunlight and to scatter it out so you can see it with your eyes. And so this is the Tyndall effect. Anytime you can see a beam of light going through something the way we can in this sort of diagram right here, that's your Tyndall effect. It will not occur in solutions because the particles are too small. It will occur in suspensions because their particles are big enough for this to work. So solutions do not exhibit the Tyndall effect. Suspensions do exhibit the Tyndall effect. So continuing here. So in between solutions and suspensions are what we call colloids. We said before that that in a colloid, so the particle size is between 1 and 100 nanometers. We said less than 1 nanometer and it's a solution. Over 100 nanometers and it's a suspension. And so this is a colloid, has those particles in between those two. The mixture in a colloid is homogeneous. The particles are spread out evenly throughout the substance. The particles generally can't be filtered. You can't get them out that way. In a colloid, they're too small to be filtered. So far, everything's been exactly the same way as a solution. You know, a solution, the particles are small, they're homogeneous, they can't be filtered. So what makes this different than a solution? Well, one thing is that if you look at the Tyndall effect, it's only very slight, which would mean this is different than a solution here. In a solution, of course, remember that the particles are too small to scatter light, and so it won't occur. You shine a laser through salt water, you're not going to see the beam. Particles are simply too small to scatter the light. So the fact we have a slight Tyndall effect tells us that we have something a little bit different going on. And it turns out that the reason why that we have to have the separate colloid as a category here is that the particles in a colloid technically should be too heavy to be homogeneous. They should filter out. They should settle out. They should be too heavy for that. But basically what happens is that in a colloid, the particles tend to all develop the same charge. And so you'll all have all positive charged particles or all negative charged particles. And so if I have my particles down here in my colloid that are dissolved into this guy, they all positive, say. If another one comes down here, it's also positive. What's it going to do? It's going to be repelled by the one that's below it. That should be positive. It looks like a negative down there. And so as a result, the next one that comes down that's also positive is going to be repelled upward. They all sort of push on each other and push each other away. And so as a result, they spread themselves out throughout the whole solution. And you end up with a homogeneous solution, or not homogeneous mixture. Sorry, not a solution. It is a colloid. A homogeneous mixture that we get out of it here. And so this charged particle aspect of this, the fact that the particles in a colloid are charged, means that they tend to repel each other. In a suspension, they oftentimes are also charged, but they're simply so heavy that they overcome that charge and settle out anyway. And so this is basically what we have for a colloid. Now, different types of colloids that we're going to run into. If I can get to it here. If it'll let me get to it. All right, so one type of colloid where you have one liquid that's dispersed in another liquid is called an emulsion. Classic example, milk. In milk, you have basically, if you know your milk, you talk about having, it has sort of cream to it, and it has sort of the liquidy part, the whey. Technical term, I believe it is. Basically, you have two liquids that normally will separate. But in milk, you've got these two liquids that would normally separate are all mixed together. It's called an emulsion. Typically, if you have liquids that normally will not mix, you have to add what's called an emulsifying agent. Soap is another example of this, that can be added to break the liquids into small particles that then can be spread out into this colloid. Typically, all emulsions are colloids. Typically, things like milk. Milk is an example of a colloid here. And so basically, it breaks up what you've got into small little pieces. These small little pockets of liquid can then basically mix up through the whole thing. And so that's what happens in milk. Other types of colloids. So an emulsion is a liquid mixed into other liquid. If you have a solid that is mixed into a gas, that's called smoke. Because you have little solid pieces, ash, that are mixed in with everything else. If you have a solid that's dispersed in a liquid, that's called a gel, like Jell-O. You basically have small little pieces of gelatin that are evenly spread out throughout a liquid, which is why the Jell-O has sort of this liquidy solid sort of thing. It's like it's halfway in between. Reason why is because it's basically got solid pieces dissolved in a liquid. So it has some properties like a solid, some properties like a liquid. If you have a liquid dispersed into a gas, that's a fog. You have little water molecules, well, not water molecules, but little, because actually in a fog, that's the difference between, like, say, when you see a fog of water vapor and just talking about water vapor. Water vapor you can't see. There's water vapor in the air surrounding you right now. You don't see it out there. The molecules are far, far too small. They're quite technically sort of in solution in the air. In fog, though, you can see it. And if you shine a flashlight through fog, you can see the beam. It's a Tyndall effect. The reason why is because that basically you have these larger water droplets. They're not big enough to fall out, because then it'd be a suspension. But they're small enough to be held out here, and they spread out throughout it sort of evenly. You get this homogeneous mixture. And so liquid dispersed in a gas is called a fog when it's a colloid. If you take a gas and disperse it in a liquid, that's a foam. And so that's the term that we use sort of for that one right there, because you have the little gas pockets that are mixed up throughout a liquid. And so you get something that, once again, is somewhat liquid-like, somewhat solid-like. We actually have gotten to the point, I haven't mentioned it up here, but there are what are called aerogels these days that basically are instead of being a solid that's dispersed in a gas, it's a gas dispersed in a solid. And for those, that's another type of colloid. Basically, you end up with something that has all the properties of a solid, but is incredibly, incredibly light. They've started making some pillows and other things like that and other pads out of them because you basically have something that's extremely, extremely light because it's mostly air, but it's dissolved into a solid, and so it has the strength properties of a solid, but has like the weight you would expect of a gas. But that's another example of a colloid. These are all examples of colloids we have here, and so that's basically what a colloid is.